I'm CK. Tonight I reached into my bag of Mitch Electronics kits. I bought 30 or so of them from Mitch Electronics a little while ago, and I'm going to work my way through all of them. And I pulled out the high-low alarm. It's an alarm that you can set two voltages, a low voltage and a high voltage, and trigger a beeper if the voltage input is outside of that range. Sounds like a pretty neat thing to learn from, and we'll put it together, see how well it works, and take a look at the web page too, because the Mitch Electronics web pages are very instructive. And I hope you enjoy the video. Here's the bag. It's got a QR code to get to the instructions. This is serial number 3, so not a lot of people have made this. We'll dump it all out into my new parts tray. I picked up more of these. These are so handy, and they're non-magnetized because I hate magnetized parts trays. And they're like $7 for 3 of them on Amazon, so very happy. Okay, let's look at the circuit board. It's got input for control power, and then the sample power that you're sampling, and then we've got another thing, high-low. I'll have to look that up, see what it is. One IC, two ICs, some resistors. Here are the three, get that out of the way. Here are the 3 potentiometers. That sets the high voltage, that sets the low voltage, and this one sets the rate of how fast this buzzer buzzes. I don't know what these chips are, and as you can see, there are no values listed on the board, so you have to have a build guide. A good quality board, again, they provide good boards. So here's some, these should be 104 caps. There's a couple of 104 caps for the ICs. This is a LM358, that's an op amp. And this is a CD4093. I'm not sure what that is. I think it's a trigger, but I'm not sure. I'll look that up later. Or it may be in the build guide, I don't know. 3 little potentiometers set the voltages. Some resistors. 1 big old electrolytic cap. And an LED. So not a lot of parts, which is just fine. Let's look at the build page, which is where I find this Mitch Electronics really shines. High-low alarm sounds a beeper when a measured voltage becomes too small or too large. It uses the 358 as a dual comparator. That's what op amps can do, to detect both high and low conditions. And the 4093 is a quad NAND Schmidt trigger, so that's what's going to be generating the tone on the buzzer. Oh good, look at this. Nice little schematic. They do a real good job on this. And you'll see how the comparator works here, and then triggering the transistors. Then over here we've got the powering the 358. And then, okay, here's J3. Oh, it says alarm out. So I guess the high alarm and the low alarm trigger signals can come out of J3 if you want them, which could be handy. Oh, look at this, good. It's got an animated simulation of how it works, and that's pretty good. So you can, again, learn a lot from this. And you can change simulation speed. Oh, you could change the simulation speed if I was using it on a computer. I'm not sure. Oh no, run stop does work. You can mess with that. In fact, you can go to the Mitch Electronics website and just play with this yourself without even buying the kit. And component list, circuit board, picture of it finally done, which is okay. No other build pieces. This second time or third kit I've made from them. And yeah, they don't really give you step-by-steps. They say, put the resistors, put these things in, and then go. So no step-by-step build guide, but you can see where everything is and where it all goes based on the bill of materials here, or component list. So that's what's in it. Looks like it'll be pretty simple to build, but it's a handy little unit when we get done. So I'll get the soldering iron heated up and we'll put this guy to work. Okay, let's get this fella together. We're going to start with the resistors, and we'll start with 200 R resistors, 100 ohm, and the pictures are wrong. So brown, black, black, which is what he's showing here, that's a 10 ohm resistor. Yeah, that's a 10 ohm resistor, and because what we should have is we should have a brown, black, brown, brown, black, brown, gold is 100 with 5% tolerance. Gold is 5% or less tolerance. And his picture is wrong. That's interesting. Let me check some of the other ones he's got. For his 10K, he's showing brown, black, brown, which is what I have there. So what else does he have in the brown section? See, he does he's got brown, black, red as 1K, but these, went to sleep. So brown, black, brown, gold. Oops. Wow, I always do that wrong. Brown, black, brown, gold. That's 100 ohms. So that's what we should be working with, and not brown, black, black. R1 and R6. So we'll just put R1 in first. This is why we always check our stuff with a meter. If you don't have color bands memorized, which I'm sure many of you don't. There are so many other tools now to use. Memorization of color bands is pretty much for old people like me. Let me get a little bit of solder. And we'll solder this in, see how it goes. And as usual, goes very well. And we can see it's through-hole plated. Oh, I got that one a little crumpy. It's okay. You can see the solder flowed through to the other side, which is what we want. Now we'll do R6, and we'll go through the rest of the resistors. There's not much more to say about the resistors, so I'll put the video in fast playback. You really got to bend the leads close to the resistor body on these. Put the cameras in fast playback, put all these on, and you can enjoy resistor time. And that's it for resistor time for this kit. Again, all the other color bands were right. It's just the 100 ohm was not right. So just be careful with that. And just as, particularly if you're just starting out, always just put the resistors on a meter to make sure they're right, and just so you can start getting a better sense for resistor color bands. You probably should, even though we've got things like this calculator I just was using, which I have a video of. It's a kit. I put it together a couple of years ago. I may remember to put a link in the description, I may not. So putting the sockets on now, and I just put that one in, and it's a little up on one side. I only put one leg soldered, so I'll reheat that solder, push down, and there, that flattened it out. And again, we'll take the other socket and do the same thing, making sure that the notch in the socket is matching the notch on the circuit board. Put it there, rest it on my pinky finger behind the board, on the back there. Do one leg, let the solder cool. Always let the solder cool, because I have done this many times. When I let go too soon, solder wasn't cool and it moved. And then you just have to do it all again. Now I'll do all the other pins on these sockets. And there's the sockets on. Now we'll do the next. We do it in order of how things, height of things is. So I'm going to put the variable resistors, the potentiometers, on here now, just because I feel like it. They are all the same value. They're all 103s, so that's 10K, because it is 1, 0, and 3 more zeros. So that's 10,000 ohm maximum resistance. Let's see, I think I'll put the transistors on. Actually, I'm going to put the 104 decoupling capacitors on. Where's my... I don't try to peel these out of this paper tape, I just cut them off. Because I found that if you try and peel them, well, you'll do silly things like rip the base of the capacitor material, or you'll break a lead or something like that. So I just cut them loose. These condition the power going to the chip, giving it a little energy storage to buffer for high or low voltage conditions. You can see it going. Where's my pointy thing? You can see going to the trace right to the power in on the chip. And if you ever look up the data sheet for a chip, which you should, it's good to look at the data chips and learn about what they are, data sheets for chips, and learn about what they do, and it'll give you a sample implementations, how to wire them or lay them out on a board, and those will show you where the decoupling caps go. So now we'll put the 3 transistors on. They're all 3 are the same. I didn't put the diode on. Where did the diode go? Oh, there it is. Make sure, of course, with the transistors, the flat side matches the flat side on the printing on the circuit board, and in this case, for example, these two have the flat side facing this way. This one has the flat side facing that way. So always double check. Now we'll put the diode on. It's got a silver band on it, which will match the white stripe on the circuit board. Now we'll put the, what is this, 100 nanofarad microfarad cap right here. The shaded side is negative. Actually, I'm not. Yeah, shaded side is negative. You can also tell, because I can't really, I hesitated because he's got around the negative lead. The solder hole itself is round, but it's just got, the shading has a square cutout, and it confused me a little bit because typically the square solder hole is for the positive lead, and it is here. This is square, this is round, but that gap in the shading threw me off momentarily. And we'll leave that to solder in a second. I'm going to put the little buzzer on, and there's the positive side. And as you can see, there's a little plus sign, and the hole is square, indicating that's where the positive lead goes. These are a little harder to bend. And now I'm going to go ahead and put the two diodes in too. Now diodes are backwards, by the way. Diodes, I'll show you. The diodes, the negative lead is, so I'll go into continuity mode on here, because that puts a little bit of power through the leads, and we can see I'm holding the negative lead against the short leg, positive lead on that side, and you'll see it light up. And you'll notice this is a square pad here, and that's negative for diodes. I know, I don't know why they ever did that. I think a couple of people just weren't talking, and it just became part of the lore. Now we'll put the two ICs in. I'm going to bend the legs inward just a little bit against the side of my workbench, because they're often splayed out a little bit. There's a little notch there that will want to match the notch on the socket and the circuit board printing. Press that home, make sure no pins are bent, make sure it's all flat. And that's the thing that's going to make buzzy sounds. And this is the op amp, same thing, notch to notch, and the op amp is going to, it's got two op amps in it that it's using. Let's see if we can get back to that picture. Oh no, it's right there. See, it's using two of the op amps in that dual package to sense both the low and the high value of the input voltage. So let me get my Nipex and we'll do some simple wiring. Reasonably short on one end because that's going through the circuit board, a little longer on the other end because I'm going to be putting that through or connecting a power supply to that with alligator clips. So I want to have something to grab onto. So we'll put the red lead through first. For VCC, that's voltage in to drive the electronics, not the voltage you're sensing, but the voltage that's powering this whole contraption. And black for ground, as is traditional. Now we'll do the same thing with the voltage sensing. Oops. Twisting them in my fingers. And we'll use a green wire for the sensing positive, just so we don't get confused. And that goes into V in. And the black wire goes to input ground. And while all these leads are sitting here, I'm going to tin them a little bit just so they don't fray and I can get a good connection when I clip something on there. Just a little bit of solder to make them not fray. And there we are. I'll peel the protective tape off the buzzer. And here we go. We've got a couple of 4 mounting holes. If you want to put it in a project box or screw it down to something. Now I'll get some power supplies and we'll get this thing working. What I've got set up here is 2 different power supplies. This is the nominal 5-volt input to drive the circuitry. This is the voltage under test. As you can see right now, I've got it set it at 1.6 volts, only because that felt like a fine voltage. And that is between the high level and the low level. Now if I turn the low level down, if I say, oh no, that's fine. If I turn the low level up and say it goes above 1.6 volts, it'll beep saying, oh wait, that's too low. So if I turn the voltage up to 1.9, the low voltage signal goes out. Same thing with the high voltage. If I turn that counterclockwise, there, it's saying 1.8 is too high for me, so I'll turn it up to there. Let's see what that triggers at. So about 3 volts. I've set the high voltage to 3 volts in that position. I can go even higher. And as you can see on these, it's 0 volts to VCC. So whatever your voltage going in, that's what's going to be the limit on your testability. So 5 volts is basically the range. So I've turned it up about 3 volts. 3.3 volts. Says it's too high. I'm going all the way up to, oh, that didn't trigger anything. Huh. So it's like its upper limit is 3.3 volts. Because I'm not getting any variance in that range. Let me take this down to 2.8. It'll cut out there and then go up to 3.3, 3.3, and even if I go all the way up, that's another 1/8 of a twist, it still doesn't turn off. So it only goes, maximum input sensing height is 3.3 volts. Interesting. Probably, I wonder if that's VCC measured after all the drops or not. That's interesting. But that's the way it works. Oh, we'll do one other thing just for fun. And this potentiometer changes the buzzer rate. By controlling what's going into here. So that's it. Let me turn this off before it drives me crazy. And that's it. And again, the schematic and the simulator on the web page will show you graphically what's happening inside all these components. And it's another good little kit from Mitch Electronics. We'll be looking forward to another one in the next week or two. And I hope you enjoyed the video.